So what is algorithm here? It is a process of performing arithmetic as well as arithmetic numerical. The characteristics of algorithm. So a well-known algorithm must has 5 basic characteristics. Flowcharts are categorized into 2 types: program flowchart and system flowchart. Hello to all, a warm welcome to my new session on planning a computer program. I am Revati from the Department of Computer Science, Vidhyaashram, First Grade College, Temple of Excellence, MYSURU. So dear student, what are you waiting for? I know how to write a program. Before that, let me to recall the topic which I have discussed in my last session of this unit. So dear student, I started with introduction about software. Along with that, I have discussed the 2 different type of software, that is application software as well as system software. Along with that, I have covered introduction to computer language. In that, I have discussed high level language, low level language. Under low level language, I have discussed machine level language as well as assembly level language. Along with that, I have discussed language translator. What are the different kinds of language translator we are going to have here? That is assembler, compiler as well as interpreter. Along with that, I have covered linker as well as loader. Along with that, I have covered utility software, and these are the topic I have covered in my last session of this unit. But dear student, in my today's session, I'm going to deal with algorithm. Along with that, characteristics of algorithm. Along with that, I'm going to deal with flowchart as well as pseudocode. Anyway, dear student, let's learn how to write the algorithm. So, dear student, as we know that before going to write any program, what I want to do, I want to write the flowchart. So, I want to find the solution, whatever the problem it may be, but I want to find the solution, and where I'm going to represent the solution, that is in the form of algorithm. So here, algorithm is a step-by-step procedure to solve a given problem. So here, what is algorithm? It is a step-by-step procedure to solve a given problem. Now, let me to take simple example here, that I want to design a calculator. So, to design a calculator, what are the things I required? I required numbers. That is nothing but digit, that is 0 to 9. After that, I required addition operation, multiplication, division, as well as I required subtraction. Along with that, modulus I required. Along with that, I required to clear the result, and I required equal symbol. Why I required equal symbol? To get the output. So here, these are nothing but the step-by-step instruction. That means first I'm going to define what are the numbers I required. That is 0 to 9 numbers I required. After that, what are the operations I want to perform? That is addition, subtraction, so and so. After that, what I want to do? I want to display the result to the user. After that, once again, I want to clear the screen. So here, I'm going to give the instruction one after another. Similarly, if I take any programming language, I required algorithm. That means whatever the problem it may be, before start implementing, first I want to write the algorithm. Based on the algorithm, I'm going to write the flowchart. After flowchart, I'm going to start the implementation procedure. So here, what is an algorithm? It's a step-by-step procedure to solve the given problem. So here, what is this algorithm? What's the meaning here? It came from the word algorithm, which means that process of doing arithmetic and Arabic numerals. So what is algorithm here? It is a process of performing arithmetic as well as arithmetic numericals. The characteristics of algorithm. So a well-known algorithm must has 5 basic characteristics. First one is input. That means I want to specify how to get the input or how to give the input. So the algorithm starts with the procedural step to accept input data. So algorithm must have one or more data to be processed. So here, if I consider any problem, we don't know how many input we required. But while designing algorithm, I want to design in such a way that it must capable to read all the inputs. So algorithm starts with procedural steps to accept input data, and algorithm must accept one or more data to be processed. My next step here is definite. So each operation must be specified. So whatever the operation I'm going to perform, that must be defined clearly. So each operation step or operation must be definite. That means each and every instruction must be clearly specify that what should be done. So while defining algorithm, I want to specify the operational steps properly. So I want to specify clearly what operation should be done by the algorithm. Now, the third characteristics here is effective. So what is this effective? Each operation step can, at least in principle. So each operational step must be carried out by some principle. So person using paper and pencil in a minimum number of times. That means while designing any algorithm, person may able to take the pen as well as pencil in order to write the operational steps. So here each operational step can, at least in principle, is carried out by a person using a paper and pencil in a minimum number of times. So before start implementing, the user or programmer want to write the algorithm. So while writing algorithm, he or she can able to use paper as well as pencil to write the algorithm, and it must have minimum number of times. That means whatever the operations which is carried out by the algorithm must be specified in minimum number of times. Then I'm going to have terminate. So what is this terminate here? After some minimum number of operation. So in the effective characteristics, specifically I'm going to specify these many operations I required, or these many steps I require to complete my operation. Once the algorithm is done, now what I want to do, I want to write the termination step. That means once the minimum number of operations algorithm must be come to an end. That means once the minimum number of operations are done in an algorithm, then the algorithm must be reached at the end. So here, after some minimum number of operation, algorithm must come to an end, and after that I'm going to get the output. So an algorithm is written to solve the problem. Why I required algorithm? Because to solve the problem, I'm going to take the help of algorithm. Therefore, it must produce one or more computed result. That means if I take any algorithm, okay, it must capable to produce one or more output. So here an algorithm is mainly used to solve the problem. Therefore, it must produce one or more computed result, or answer is called output. So what are the characteristics of an algorithm? That is input. Along with that, it must have definite state. Along with that, it must be effective. It must have termination condition, as well as it must generate output. Now, I'm going to have the example here. So this is the algorithm. So dear student, this is very, very important from the examination point of view. So what is an algorithm? It is a finite number of steps used to solve the given problem. That means I must specifically define that these many steps I require to solve the given problem. Along with that, I'm going to write the procedure that how to solve the problem. So here an algorithm is to find the area of a rectangle can be expressed. So what is the area of a rectangle? That is length and breadth. So area of a rectangle is length as well as breadth. I required input. What is the input here? I required length as well as breadth. So dear student, first what I want to do, I want to start my algorithm. So what is my first step in my algorithm? That is start. So in my step 1, what I will do, I'm going to start writing an algorithm. So what is my step 1? It is start. In my step 2, what I want to do, I want to read length and breadth. So I'm going to read two values, that is length and breadth. So in short, I'm going to write input or read L and B. L is nothing but length, B is nothing but breadth. So dear student, in my step 3, I'm going to calculate area of rectangle. So what is the formula to calculate? That is rect equal to length into breadth, because I want to get the area of triangle. So I'm going to write the calculation part in my step 3. And if I go with step 4, after calculating area of a rectangle, what I want to do? I want to display the area. So display means what? It is output. So output rectangle. That is area of a rectangle. And in my step 5, I'm going to end my algorithm. So it is stop. So here I'm going to specify these many steps I require to calculate area of a rectangle. So this is step by step finite number of instruction. In my algorithm, I'm going to define step by step. That means after one step, what is my next step? And I'm going to have finite number of procedure. So it is not infinite. I know when to start and I know when to stop. So it is finite number of steps. Now, I'm going to have another algorithm, that is to find the average of 4 numbers. What is the given problem? To find the average of 4 numbers. Think that I have 10, 20, 30 and 40. So these are my numbers, and from where I'm going to get the number? From the keyboard. So what I want to do? I want to read these numbers. After reading, what I want to do? I want to find the sum. After sum, I want to find the average of these numbers. I know what I want to do. I want to read the input, perform the calculation, display the output in general. Okay, but if I translate this to algorithm, then at the beginning, I'm going to have my step 1. In my step 1, I'm going to start my algorithm. Next step, I'm going to read 4 input. For example, say A, B, C and D. After reading, what I want to do? I want to add those 4 numbers and I want to divide those number by 4. That means sum divided by 4. So here in my step 3, I'm going to perform the calculation. So what I will do at the beginning, I'm going to add A, B, C and D. And whatever the result I'm going to get after adding these 4 numbers, I'm going to divide that number by 4 in order to get my average. Now, in my step 4, what I'm going to do? I'm going to display the average. And in my next step, what I'm going to do? I'm going to stop my algorithm. So this is nothing but the example for an algorithm. This is the way I can able to write my own algorithm. Now, dear student, I'm going to have another very interesting topic, that is flowchart. So what is flowchart? That means I want to represent the flow of algorithm in pictorially or in some chart. How? What I required here? I required some symbols. With the help of some symbols, I'm going to write the flow of an algorithm. So what is flowchart? A flowchart is a pictorial representation or graphical representation of an algorithm. First, what I want to do? First, I want to write the algorithm. After writing algorithm, what I want to do? I want to convert that algorithm into flowchart. How I'm going to convert algorithm into flowchart? That is nothing but I'm going to represent the pictorial representation here. That means whatever the algorithm I'm going to have, I'm going to write it pictorially, or it's nothing but the graphical representation of an algorithm. So dear student, here flowchart plays very important role in programming, and it also helpful to understand the logic of a program. So dear student, once I done with flowchart, then I can able to start my next step. So what is my next procedure? That is nothing but the implementation. So once the flowchart is drawn, it becomes easy to write program. So writing program is nothing but the implementation, and that can be done by using any high-level programming language. It may be C, C++, Java, etc. Now, there are 2 types of flowchart. That means flowcharts are categorized into 2 types: program flowchart and system flowchart. Anyway, dear student, let's see what is program flowchart. So here, present a diagrammatic representation of a sequence of instruction for solving a problem. So program flowchart means what? Whatever the problem we have, for that I'm going to write the algorithm, and once I done with the algorithm, the next step is to convert that algorithm into flowchart. So it's a diagrammatic representation of it is a pictorial representation of a sequence of instruction, that is nothing but step by step instruction used to solve a problem. Then my second type here is system flowchart. So what is system flowchart? Indicates the flow of data throughout a data processing system. Here, system flowchart is nothing but, once again, it is a flowchart, but it is mainly used to represent the flow of data throughout a processing system, as well as the flow and out of the system. That means how the data flows into the system and how the output gets from that. So here it is a processing system, and it is mainly going to focus on flow of data as well as out of the system. So such flowcharts are widely used by designer to explain data processing system. That means in data processing system, how the data are flows. To explain that, we are going to use system flowchart. Now, why I required flowchart? What are the importance of flowchart? Let's see one by one. So communication. So what is this communication? Flowcharts are better way. So here flowcharts are the better way of communication of the logic of a program. Suppose if I want to communicate the logic of a program, then I require flowchart. And effective analysis. With the help of flowchart, programs can be very easily analyzed in more effective way. And proper documentation. Program flowchart serves as a good program documentation. So here in the flowchart, we are going to transfer the algorithm into flowchart. So it is a better documentation that covers or that gives complete information, which is needful for various programs. That means I can able to refer that program for some other programs. Now, efficient coding. The flowchart act as guide or blueprint. So here, flowchart is going to act like a blueprint or guide during system analysis and program development phase. So the program development phase mainly depends on the flowchart, and whatever present in the flowchart, same thing they are going to code. Now, proper debugging. The flowchart also helps to debug errors. So here the flowchart helps in debugging process. So here debugging means what? Finding the errors. Efficient program maintenance. So here flowchart helps to maintain the program efficiently. So the maintenance of a program become easy with the help of flowchart, and these are the importance of flowchart. Now I'm going to have some of the symbols. So dear student, we know that algorithms are represented as a flowchart, or it is graphic representation, and to represent graphically I require some symbols, and these are the symbols used to draw the flowchart. So at the beginning I'm going to have vowel. So this is my vowel symbol, and It is nothing but the terminal. It is mainly used to start or stop the process. So here the beginning or end or point of interruption in a program. So here I'm going to use vowel symbol to represent where to start. That means from where I'm going to start the program and where I'm going to stop the program. So dear student, followed by vowel symbol, I'm going to have parallelogram. So what is the need of parallelogram? To read the input and to display the output. Suppose if I want to perform any reading process or any writing process, in that time I'm going to use parallelogram. Now I'm going to have rectangle. So what is the need of rectangle here? To perform any calculation or whatever the calculation steps I have in my algorithm, that is written inside the rectangle box. So it is known as processing. An instruction or group of instruction which changes the program. That means all the calculation parts are written inside the processing. Then I'm going to have the preparation. Why I required preparation? Because the symbol is different from all the above three symbol. Because whenever I want to perform any repetition or looping, in that time I'm going to use preparation, an instruction or group of instruction which changes the program. So here in my preparation, I can have one instruction or group of instruction, but it's going to change the program. Moving further, I'm going to have rhombus. So what is this rhombus? That's nothing but decision making or branching. To represent decision making, I'm going to use rhombus. So, represents a comparison, a question, or a decision that determines alternative paths to be followed. That means in my algorithm, if I have any comparison or any questions or any decision making, in that time I can go with rhombus. Now I'm going to have predefined process. So what is this predefined process? So dear student, I'm going to use this predefined process to represent functions. That is nothing but the subprogram. So a group of operations not detailed in the particular set of flowchart. That means when I have separate subprogram and I'm going to write all the detailed operation in my subprogram, and to indicate that I'm going to use predefined process. Along with that, I'm going to have the connector. Why I required connector? To continue the connectivity of flowchart. An entity form and exit to the another part of program flowchart. So while drawing flowchart, there are certain time I cannot able to draw the flowchart in one page. And if there is any continuation in my next page, in that time I want to establish the connection between flowchart. In that time, I'm going to use circle. That's nothing but the connector. Now, I want to show the flow of direction. That means how the program flows, how the data are going to move. All those things are carried out with the help of arrow. So here, flow direction, the direction of processing or data flow. to represent the flow of data, I'm going to use arrow symbol. Now, I'm going to have simple example to find the area of a circle. So, first what I want to do, tell me. So, dear student, whatever the problem I'm going to get, first I want to understand the problem. So, what is the problem here? I want to find the area and circumference of circle. So, area, what is the formula to find out the area? It is 3.1214 r square, that is pi r square. Then what about circumferences? It is 2 into pi into r, that is 2 pi r. Okay, for the given problem, I got the solution, that is, I know what is the formula to find out area of a circle as well as circumferences of a circle. So, this is the formula to find out circumferences and this is the formula to find out area. Now, what I want to do, I want to start writing algorithm. And what is my first step here? That is, I want to read the r. So, what is r here? That is nothing but radius. And what about pi? I know the pi value, that is 3.1214. But what I don't know here, I don't know r. And from where I'm going to get the r? That means I want to read the r. So, what is my next step? That is input or read radius. After reading, what I want to do? I want to find the area as well as circumferences. To find the area, I have 3.142, then radius square, that is radius into radius. To find the circumferences, I am having the formula, that is 2 into pi r. So, I have pi value, that is 3.142 and radius. Okay, after finding area as well as circumferences, I want to display the output. So, what I want to write or what I want to print here, that is area as well as circumferences. And once I done with the printing, I just want to stop the flow chart. For that reason, I'm going to write stop. Now, dear student, this is my algorithm. Now, I want to convert this algorithm into flow chart. So, this is nothing but the pictorial or graphical representation of an algorithm. So, here I'm going to write the start word in the vowel or inside the vowel, and whatever the input I want to read, okay, I'm going to write the input within the parallelogram. After that, I'm going to have the rectangle to perform all the calculation. So, what are the calculation I want to perform? I want to find the area as well as circumferences, and I'm going to write that inside the rectangle box. Once I done with area as well as circumferences, I just want to output the area as well as circumference. So, I'm going to use the parallelogram once again to output area as well as circumferences. Once I done with printing, I just want to stop. For that, I'm going to use stop. Now, I'm going to have another example, that is draw the flow chart as well as algorithm to find the largest of two numbers. So, what is the given problem here? I want to find the largest of two numbers. So, what I required here? I require two numbers. And from where I am going to get two numbers? from the keyboard. That means I want to read two numbers. Say A and B. My input is A and B. Now what I want to do according to the given problem, I just want to cross verify that which number is larger. So what I want to do, I want to check A is greater than B or not. So here, if A greater than B, suppose A is larger than B, then what I want to display? I want to display else B is larger. Then I want to end my if statement and I want to stop my algorithm. See here, how many steps I have here? Only 4 steps. So I have only 4 steps and I'm going to use statement to check the given number is larger or not. Now this is my algorithm. Now I want to write this one in the form of flowchart. So I start writing vowel. Okay, here I'm going to start my flowchart and I'm going to read two input, that is A and B. So where I'm going to place in my parallelogram. Now I have A value as well as B value. For example, 20 and 5. So A is 20 and B is 5. Now I just want to check 20 greater than 5. So I'm going to check 20 greater than 5. If this condition is true, I just want to print 20. So here 20 greater than 5, the condition is true. I want to print 20 and I want to stop the execution. Suppose if I have 10 and 35, A is 10 and B is 35, that is 10 greater than 35. If this condition is true, what I want to do, I want to print A. But this condition is false because 10 is smaller than 35. So what I want to display, I want to display B and I just want to stop the execution. This is the way I'm going to convert algorithm to flowchart. Now I'm going to have pseudocode. So dear student, once I done with algorithm as well as flowchart, my next step is to pseudocode. So this is an abstract representation. So here pseudocode is nothing but the abstract representation of program in English statement. So whatever the pseudocode I'm going to write, there is nothing but the just representation of programs in terms of English statements. So here in pseudocode, English words, phrases are used to represent operation. So in my pseudocode, what I'm going to do, I'm going to use English statement to represent operations. And what is the advantage of pseudocode here? That is very easy to read, very easy to understand and very easy to modify. So dear student, in my today's session, I started with how to write a C program. That is, what is the planning, how to convert algorithm to flowchart, then how to start implementing. I hope, dear student, in my today's session, you got more information about how to write C program. Anyway, dear student, this is the last session of this unit. Let's meet in the next unit, that is anatomy of computer. Until that, keep watching and keep learning. Thank you.